3, that's good. And then let's do -1. If I can get it there. There we go. Okay, now notice, so try to get your sliders to be whole numbers and notice what our x-intercepts are. Okay, so when we move the sliders around, the thing that changes about our graph are the x-intercepts change location. Okay, so you can highlight your x-intercepts and then slide around these values and look. And so here, my Q is now 3.2, just like my Q is 3.2 right here. So my x-intercept is 2, my Q was 3.2, but these are both still +1 and +2, okay? The opposite value of these. Okay, so if we, let's see, experiment with moving the center location. We look at step 7. It says graph each of the following functions and fill out the table. So let me get rid of these little slider guys. So this one is going to be x minus 10. And this one is going to be plus 2. And then this one is going to be minus 5. So when I graph this, first I need to zoom out so that I can see everything. And then I highlight my x values. Notice that those x value, or my roots right here, are the same value but the opposite sign of what was inside of our function. So our x-intercepts here are -2, 0, 5, 0, and 10, 0. Okay, and you can see, so our -2 corresponds to this 2 right here. Our 5 corresponds to this -5. And then our 10 corresponds to this -10. So they're the same value, opposite sign. So we can go ahead and do this for the next ones as well. So we have +7. This is long. +3 and -8. Okay, so notice I have -7, -3, +8. So I'm going to put those in. So -3, 0, -7, 0, 8, 0. Those are my 3 x-intercepts. And last but not least, I have just x by itself, then +1, then -4. And when I highlight, I'm going to zoom in first and highlight my roots, I get one at -1, 0, 0, 0, and 4, 0. Now, you may ask me, Miss Roberts, where on earth did this 0 come from? It comes from right here, where we have, this is technically x plus or minus 0, okay? But if we add or subtract 0 from something, it just goes away. So our x corresponds to this guy. Our +1 corresponds to this guy. And our -4 corresponds to this guy. I forgot my other parenthesis. Sorry about that. Okay, there it is. Okay, what pattern do you notice? So the roots have the same value, but opposite. Let me zoom out. Sign as the numbers in each factor. And by factor, I mean one of these little guys right there. Okay. Okay, we're almost done. Step 8, it says graph each of the functions and fill out the table. So I am going to do this by filling in, so x plus 2, and then I had x minus 1. Get rid of that guy. So this is the first one, and I'm going to cheat, and I'm going to copy this into the next thing, and they're just going to be, so this next one is squared, This next one, it has a cube. The next one has a fourth. And the next one has a fifth. Okay, and I'm gonna unhighlight everything as I use it so that, or like when I'm not using it, so that I only see one at a time. Okay, so for the very first one, it asks, does the function touch or cross at x equals 1? So if I go over here, x equals 1 should be one of my roots. So if I go to the positive side and click it, right here, it crosses, it passes through. There's parts of the function on either side of the x-axis. So it's going to cross. Oh my goodness, if I can write. Okay. Then we already went through the second one. It touches right there. So let's move on to the third one. So notice right here, there are parts of the function on either side of that. So it should cross. And then let's unhighlight that and go to the fourth. This one just touches at x equals 1. It goes and touches and then goes back up. If you look on this bottom side of the x-axis, there is no green. So it's just touching. And then let's unhighlight that and go to the fifth. Unhighlight. Fifth. And this one has purple on both sides of the function. So it's going to, or on both sides of the x-axis. So it's going to cross. Okay, sweet. So what pattern did you notice? So notice every time we have cross, let's see what our power looks like. So every time we cross, let's just highlight the whole thing. Our power, technically here, our power is 1. Okay. Here our power is 3, here our power is 5. That's the only thing that changed between each of these. Now let's look at touch. It was 2 and it was 4. So the common theme between those numbers, 1, 3, and 5 all crossed. And 1, 3, and 5 are also odd. 1, 3, and 5 are odd. Okay. Then 2 and 4 touched, and 2 and 4 are even. Okay, so this is going to tell us when we have a power over a particular factor, if that power is odd, our function will cross through that point. If our power is even, it will just touch at that point. So again, so 5 x to the, or 1 x minus 1 to the 5th, this purple function over here, 5 is odd, it crossed. So you have purple both below the x and above the x. Now let's look at to the 4th, which was even. At x minus 1, or x equals 1, we have, so this is even, we have only green on top of the x-axis, none below, so it just touches, okay? So let's look down. It says for each function below, predict where it would touch and cross the x-axis. So here, both of these have a silent power of 1. So it's going to touch nowhere because 1 is never even, okay? And it's going to cross at x equals -10 and x equals 2, okay? Zoom out a little bit. Actually, let's switch to this. And you could confirm this by graphing it on Desmos if you would like. Okay, now here we have a power of 1 and an even power of 2. Okay, so it's going to touch at x equals 4 because this one has an even power, and it's going to cross at x equals 3 because this one had an odd power. And remember, we're taking the same number but switching the sign. Then here it touches the x-axis, so we have an even and an odd. So it's going to touch the x-axis at our even power, which is going to be at x equals -2 because we switched this sign. And then at our odd power is where it's going to cross, and our odd power here is going to be when x is equal to +8. So I'm going to go ahead. So these were all odd. Okay, So odd is where it's going to cross. And so we had this, so cross, cross, cross. These were even. Even is where it touches, so we touch in those places. Okay? All right, so that's the whole investigation. Then there's this practice on the back. Okay, I'm going to go ahead and go through this practice with you. We did the first one together yesterday. Graph an example of a cubic function with a negative leading coefficient. A negative leading coefficient has to start increasing and then go to decreasing. Okay, so it's the opposite of the one on the left that we did last night or yesterday. It was last night for me. Then here, graph an example of a cubic function with a positive leading coefficient and only 2 real roots. So I want it to pass through one time, and I don't want it to pass through again. I can just cross. And so this will give me 2 roots right here. Okay, roots there and there. And this is positive because as I move from left to right, it goes from going down to going up. Okay, that's how we know it's positive. And also your cubic function doesn't have to look exactly like mine. There can be variation with this practice. Then it says graph below an example of a cubic function with a negative leading coefficient and only 1 root. So this time, I'm going to keep my little minimum away from the x-axis. As I move left to right, I end up going down, and I only have 1 root. Okay. Graph a function, or graph below an example of a function with a degree of 3, so still cubic, a positive leading coefficient, and 3 real roots. So this time, I want to pass through as many times as possible. I want to start on the left, I was going down, and then as I move to the right, I end up. So this has a positive leading coefficient. And then it says graph below an example of a quadratic function with a negative leading coefficient. Quadratic, negative leading coefficient means it's down. Okay, just like that. All right, so that was the whole investigation and all of the practice. Those are the solutions. Thank you so much. I will see you guys later.